Then the theorems that are here. The reason that I did these together like this, and the reason I printed them, is that you'd find that this is in 2 sections in your book. This is actually out of section 3.2, and this one you wouldn't find until you got to section 3.3. But I really saw no reason to teach them separately because they literally are opposites of each other. This states that you have 2 parallel lines. So it starts out with the lines being parallel. And it tells us that same side interior angles would be supplementary. In other words, they're going to add up to 180 degrees. So you'll notice in the picture, the lines start out as being parallel. If the lines are parallel, then I know that angle 4 and angle 5, because they're same side interior angles, have to add up to equal 180 degrees, which is what you see over here. Likewise, angle 3 and angle 6 would add up to equal 180 degrees. Now, they only add up to equal 180 degrees if the lines are what to start with? Parallel. So now let's talk about why I did the other group with it. The converse says you have 2 lines and a transversal. It didn't say the 2 lines were what? Parallel. It didn't say that. But it said if I know that angle 3 and angle 6 add up to equal 180 degrees. In other words, if I know that same side interior angles are supplementary, what can you tell me about line L compared to M? That they're parallel. Makes no sense to teach this in 2 separate sections when one says if I have parallel lines, same side interior adds up to 180. And in the next section it says if same side interior adds up to 180, then the lines are parallel. They're exact opposites of each other. Everybody see the connection between the 2? On the sheet of paper that you have, you'll notice that the first one is going to come from section 3.2, but this one actually comes from section 3.3. The first one states that the lines are parallel. The second one is what you'd use to prove that the lines are parallel. If the lines are parallel, then this theorem, Theorem 3.1, says that alternate interior angles will be congruent. Angle 4 would be congruent to angle 6. Angle 3 would be congruent to angle 5. If I know that 4 is congruent to 6, then I would know that these 2 lines would have to be parallel to each other. Everybody see the connection? Same on the next one, corresponding angles. It starts out with the lines being parallel to each other. They gave me that part. And it said then that my corresponding angles would be congruent. In other words, angle 1 is going to be the same as angle 5. In fact, 3 would be the same as 7, and 1, 3, 5, and 7 would all, in fact, be the same. Why do I know that all of those would be the same?
Because they're, what's the word?
That's what I'm looking for. Why do I know 1 and 3 are the same? Somebody said it. They're vertical. So I know that 1 is congruent to 3. I know that 3 is congruent to 5, and 5 is congruent to 7. Likewise, I know that 2 and 6, they're corresponding, but they'd also be congruent to 4 and 8. Okay? Now, the converse is also true. If you know you have a pair of corresponding angles that are congruent, in other words, 2 is congruent to 6, then I would know that these two lines had to be parallel to each other. Everybody okay? This obviously came from 3.2. This came from 3.3. They're in different sections of the book. You know what that means? I've got to print one more. That's what that means. I've got to print one more. I have the second page printed already, though. Arvin? Here, just pass it over to Arvin. I got to print the first page of that for you in a minute, but it's going to take me a minute. Or 10. Whatever. Okay. The last theorem here is alternate exterior angles. It's the same thing. It's set up the same way. This came from section 3.2. This came from section 3.3. We're just putting the two sections together. And it says that if the lines are parallel, then alternate exterior angles are congruent. So 1 is congruent to 7, and 2 is congruent to 8. The nice thing about this is, then if you know that two lines are parallel, if I know that these two lines are parallel to each other, at least make them look parallel, and I have a transversal, okay? I've been told that these two lines are parallel. If I give you one of these angles, you should be able to give them all to me. If this one's 100 degrees, how big is this one and why? It's 100 because it's corresponding. How big is this one? 100. It's vertical or alternate exterior. How big is this one? It's vertical, alternate interior, or corresponding. How would I go about finding the one that's missing? Subtract it from 180. This forms a linear pair. These would be same side interior or corresponding. This would be alternate interior, vertical, same side interior. And this would also be 80. Does everybody see that if they told you the two lines are parallel and they give you one of the angle measurements, you can literally find them all? Everybody good? Now, Arvin, this is actually on your sheet. I got to print the first page for you. But this is on the page that I gave you. This is where the examples begin. This actually came from section 3.2. All the rest of the examples came from section 3.3. I know this came from 3.2 because it shows me that the lines are what to start with. It shows me the lines are parallel. So this came out of section 3.2. The first thing they asked me for are these two angle measurements. So I'm looking for the measure of angle 3 as well as the measure of angle 4. But they also ask me to justify it. In other words, look at the information and tell them why I know that that angle has to be that measurement. The only measurement that they gave me was this 105. So I'm going to look at where angle 3 is, and I'm going to determine how big angle 3 is from that given information. How big is angle 3? 105 degrees. Because of what reason? What type of angles are 3 and the 105? Alternate interior angles. Everybody okay with the justification? What do you mean? I did. I justified it by saying that I know that they were equal because of what? Alternate interior angles. That would be the postulate or the theorem that was used. Okay? Let's look at angle 4. Angle 4 is here. And let's look at that piece of given information, the 105. How big is angle 4, ever?
75 degrees.
Can you tell me why you know it's 75 and how you came up with it?
Because line L and line M are parallel to each other.
Right?
And so that would mean that the measurement of the angles would be the same on both sides. And since angle A would equal 105, since angle 3 equals 105, so you just subtract 105 from 180.
Same side interior angles add up to 180. These have to add up to what? 180. Now, I will say this. Once you find out information about the picture, I encourage you to take that information and put it back where? In the picture. I know that this is now 105 and that this is 75 degrees. Okay? Now, I will say that some of our justifications may end up looking different because as we add more pieces into it, there would be more ways to justify your answer. So, well, not with what's there currently, there's not. Not without putting something else in there. The only way that I could justify it is what? Same side interior. Without knowing something else first. I don't know anything else, just what? These three measurements. That's all I know so far. So the only way I could justify that being 75 is same side interior. Let's look at angle 1. How big is angle 1? It's 75 degrees. And how do I know that one for sure? Alternate interior. I think that's the last one that realistically only has one way of stating it. All the rest are going to have multiple ways that I could come up with that answer. Angle 2. How big is angle 2?
75.
It is 75. There are multiple ways that I could have come up with that. They're vertical. It's vertical to angle 1. What would be another method that I could have used? I could have used corresponding angles. Angle 2 and angle 4. Does everybody see that now there would be multiple ways that I could have shown that this was 75 degrees? And again, the more pieces that I put in, the more varieties of explanation that I could have. How big is angle 5? 105. In fact, I could at this point have said vertical. I could have said same side interior. I could have said corresponding. There would have been 3 different ways that I could list for number 5. Angle 6. How big is angle 6? 105. I could have said a linear pair. I could have said alternate interior angles at this point. How big is angle 7? Angle 7 is 105. I could have said vertical. I could have said corresponding. I could have said alternate exterior. Angle 8. 105. I could have said linear pair. Could have said same side interior. I could have said corresponding. I could have said alternate interior. Does everybody see now that there was plenty of ways that I could have justified my answer for angle 8? The more pieces that I put in, the more possible justifications there would be. Everybody okay? All the rest of the examples actually came from section 3.3. And the reason that I know that they came from 3.3 is what didn't they tell me about the 2 lines to start with? They didn't show me that they were parallel. In fact, they want me to find a value for x that's going to make the lines what? Parallel. Since I want to make the lines parallel, I am using a converse. Okay? And I have to look at where the angles are. What type of angles are they?
Same side interior.
So I'm using the converse of the same side interior angles to set up my equation. And what do I know about same side interior angles? They've got to add up to equal 180 degrees, and that becomes my algebraic equation. 2x plus 9 plus the 111 has to add up to equal 180 degrees. Now, this would justify this step. The next step really would say this: 2x plus 120 equals 180. If I had to justify that step, what would I write next to it? I could put substitution or combine like terms, but not what? Not addition, because addition says that you add things to both sides. What would my next step be? Subtraction. That would be my justification. 2x would be equal to 60. And what would my next step be? Divide, and x would be equal to 30. In other words, if x is 30, A is parallel to B. If x isn't 30, what can you tell me about line A and B? They won't be parallel. Because the only way A is parallel to B is if these two angles add up to 180. If x isn't 30, they won't add up to what? 180. They'll add up to something different. Okay? Same thing's going to happen for the next one.
Can I ask how I solved it?
Yeah, sure.
Well, since they're corresponding, you have to make it's 55
Okay, so this is the converse of what?
corresponding.
Corresponding angles. That's how we're going to set up the equation.
But instead of making them equal 180, they're supposed to be the same. So it's 55 equals 30W.
And I'm going to do 3W minus 2 equals 55. That would be the equation that got set up, because I know that they're corresponding. They'd have to be equal to make the lines parallel. What would I do next? I'd add 2, which would give me 3W is equal to 57.
19.
And then I would divide. I'd get W is equal to 19. In other words, if W is 19, line C and D are parallel. And if W isn't 19, then they're not parallel. Everybody okay with these two examples? Questions?
So to find if they're parallel or not, you plug it back into W?
I don't have to, but if I wanted to make sure, I could plug it back in. 3 times 19 minus 2 is what? 55. So I can see that these two are what? They are equal, so I know the lines had to be what? I didn't have to plug it in because the equation that I used set them what to start with? Equal. So unless I made a mistake, I really wouldn't need to plug it in. But if you want to check yourself, what should you always do? Plug it back in and see if they came up the same.
Why does the A is parallel to B? Why do you set that to 180? But
Because these are same side interior. And same side interior said they add up to equal what? 180. These are corresponding. And corresponding angles are equal or congruent. Okay? Likewise, here, this came from section 3.3. Here they're asking me which lines or segments are parallel. In other words, state which ones are parallel and justify my answer. Because they're wanting me to show that things are parallel, I am going to use a converse. Okay? And because I'm using a converse, I'm going to look to see where these angles are. What type of angles are these? They are corresponding, so it is the converse of the corresponding angle theorem. Okay, they've marked that they're congruent. That's what that mark meant. So, line BE is parallel to GC or CG. It shows that these two lines are, in fact, parallel to each other. Could I state anything about these two lines? No. I don't know anything about these two lines because they didn't give me any information about the angles that were up here on this line. So I can't assume that those lines are parallel. Everybody? They could be, but can I assume that they are? No. We'll come over to number 8. Again, because they're asking me to show that lines are parallel, I know that I'm using a converse. Look at where they gave you the angles and decide what angle type are they. These are still corresponding angles. So again, I'm using the corresponding angle converse. Okay? What would I state as parallel here?
As line segment.
Go ahead.
The ST.
The what?
The ST.
Not S2, but what? Go ahead.
PS is parallel to QT.
Okay, and I put it down here for a minute because you didn't really say what about PS. If I wrote it this way, would this be correct?
No.
No. In fact, is this a line?
No.
In fact, it is a ray, and I should start it then with S and go through P. And it would be parallel to what? It would be parallel to ray TQ.
And can I go get this out?
Yeah, absolutely. Questions?
Why is it not ST?
Why is it not ST? Did they give me anything about this angle? So, unless they gave me something about these two angles here, where it was dealing with this line, then it has nothing to do with S and T. You got to look. Sometimes it helps if you can kind of eliminate some of the picture that's there. Okay? If I just got rid of that for a minute, there's where the angles are. It had nothing to do with what's down here. It also really didn't have anything to do with this piece, did it? So they are talking about this line or ray and this line or ray, and PQ is the transversal. Does that help you be able to visualize it? Okay. Now, your assignment is there.